Pleasant morning to one and all. I am Dr. Sumitra, an associate professor from the Department of Computer Science and Engineering. Today we are going to discuss about a meta learning in deep learning. The meta learning in deep learning is a fascinating era at focus on designing algorithm and model capable of learning how to learn. It addresses the challenges of adapting a model to a new task or a domain with a minimal supervisions or a data by leveraging a prior experience and knowledge gained for learning a multiple task. The keynote in meta learning is all about the meta learning paradigm, model and agnostic meta learning (MAML), which the basic idea behind is all about training a model such that it can quickly adapt to a new task with a new few ingredients updates, learns and utilizations of the model parameter that can be fine tuned gradually or rapidly on a new task, effective for a new few shootout learning superior scenarios where data for a new task is saccharide. The metric based meta learning learns a metric space where the task or examples that are similar in the space can benefit from the knowledge transfer. The basic example is for this metric based meta learning, a prototypical network and matching network. Define a similarity metric and learns to classify the new examples based on this metric. And we have the reinforcement learning from the meta learning. The reinforcement learning is where adapt meta learning concepts to the reinforcement learning scenarios, the learning policies that can quickly adapt to a new task or the environment based on meta RL algorithms. Learn to learn where it qualify the models with the ability to generalize from the few examples or the task by learning a set of principles or strategies or the representation that facilitates a rapid adaptations. The method where the gradient based meta learning, optimizing based approaches, and the memory augment networks are the examples of techniques used to achieve this goal. And the technique which is used on this meta learning, where we have a few shootout learns, machine learning, the meta learning enables models to generalize from few examples, making it useful in scenario where label the data and sacrifice or expensive to adopt. And adaptations to the new task, models can quickly adapt to a new task or a domain by leveraging the prior knowledge learning from similar tasks. Transform learning facilitates the efficient transfers of knowledge across a task or a domain, improving overall learning efficiency and the performance. And the basic challenges are used on these the meta learning has a data efficiency, ensuring that meta learning algorithms can effectively learn from the limited data, generalize to a new task accurately, and we have scaling of metadata approaches that large scale data sets and complex data remains a challenges. The algorithm designs where designing a meta learning algorithm that's a robust adaptability and applicable across various domains. The basic examples for this meta learning can be training some models such as initial parameters can be quickly adapted to the new task or data sets with the minimal gradient updates for the typical network, and learning a metric space where the new task or examples could be classified based on the similarity to the prototype learned during a meta learning. A memory augment networks augments neural networks with a external memory to store the information about the task and examples, facilitating a rapid adaptations to the new task. A meta reinforcement learning, which we call it as meta RL, where the applies to meta learning principles to reinforcement learning technique where the agents learns to adopt their policies to the new environment or a task. As a future generation, improve the efficiency and generalization, developing a meta learning algorithm that can generalize effectively across a diversity task and data sets with a minimal computational overhead, and integrations with unsupervised learning, exploring how the meta learning can benefit from this unsupervised learning technique to the future enhancement, adaptations, and generalization capabilities. And as I conclude this by stating a applications to the real world problem, applying the meta learning to the real world applications such as autonomous system, robotic, personalized medicines, and adaptive learning system. Hence, I conclude this stating this meta learning represents a forte in deep learning research aimed at sequenced model with the ability to generalize and adapt to a new task or environment effectively. I hope you're clear with this concept. Thank you.